Okay, dear students, thank you for. Can you hear me? Okay, thank you for joining this online class. Uh, because I have to complete the portion next week. We are having the exam, so please cooperate with me and listen the class. So last class we completed with the types of softwares. We studied system software, application software. If you have notes with you, take notes. What is system software? Important MCQ. Okay, system software. I will dictate. You please take down the notes for system software. System software refers to a computer program. System software. System software refers to a computer program that manages and controls hardware components of a computer. That manages and controls hardware components of a computer. Okay, this is the system software. Already we studied last class using a diagram. The basic thing is user is interacting with the application software. The application softwares are run by the system software. System softwares are executed or run by the managed by the hardware components. Okay, this system software, it controls the hardware components of the system. It's a software. Okay, now application software, if you want, you can take the notes. Application software, it is also a computer program. Application software is a computer program that is executed on the system software. Application software is a computer program that is executed on the system software. Today we are going to study about can you see the slide? Everyone,
No,
can you see
ma'am.
the slide? Yes or no?
No, ma'am.
1 minute.
No, ma'am.
Can you see? No. Okay, wait.
Can you see the slide?
Can you see? Catherine, can you see the slide?
No, ma'am, it's still not visible.
Okay. 1 minute, you wait. So not sharing. Okay. I think now you can see the slide, I think. Can you see now?
Yes, ma'am.
Okay. Now today we are going to study about another topic, that is algorithm, flowchart, and pseudocode. It's the basic thing we have to know before going into SC programming. Okay. So first of all, algorithm. What is an algorithm? It is a set of instruction to complete a step-by-step instruction. Set of step-by-step instruction which is used to solve a given problem. So in real life example, if we see, algorithm means it is a step-by-step process. First of all, you want to do a Maggi noodles. If you want to prepare, first of all, what you will do, pour water in the pan, heat the pan, then put the masala, then add the noodles, stir it well, cook and serve. This is a algorithm for making Maggi. Okay, in real time, it's a real time example. Likewise, algorithm In order to solve a problem, we are using some step-by-step task. Okay, so again, this, see, I already told you, this is a algorithm is a step-by-step process. Step 1, pour water. Step 2, heat the pan. So step-by-step process for solving, for getting an output. What is your output? You have to get a cooked tasty Maggie. So these are the steps and procedures you will be following. Okay, likewise, what is an algorithm? See, algorithm is a step-by-step procedure for solving a problem. It is a step-by-step procedure. For example, to find the square root of a given number, first step what you have to do, you are going to start the problem. We are going to start to solve the problem. So step 1, we are using start. Okay. Step 2, what is that number? The number we need know. Which number we are going to find out the square root, that is the input. So we are using it read a number x. So input we call it as read, output we call it as print. Okay, so step 2, we are choosing the number, we are giving the input of the number. Third step, what you are doing, find the square root of the given number x. So here we are doing the calculation, finding the square root of the given number. Once we found out the square root of the given number, the step 4 is what? Printing the result, printing the square root of the particular number. As soon as we are starting this problem, starting to solve the problem, once we finish the problem solving, we are stopping the using the stop keyword, we are stopping the problem. Okay, next one. Next algorithm. Algorithm for checking whether the given number is positive or negative. What is positive or negative? If the given number. So first of all, start the process, read that particular number which you want to go to. For example, we can keep x is equal to 2. It is a positive number or negative number. We can say it is a positive number because it is greater than or equal to 0. If the number is greater than or equal to 0, then it will be printing positive. If it is less than 0, then the particular number 2 is negative. Okay, so this is the algorithm for finding, to check whether the given number is positive or negative. See, we are starting the number, reading means that input number. For example, -3. We are giving as an input number x is equal to -3. So we are checking if -3 is greater than or equal to 0. It is -3, no. So it is not greater than or equal to 0. So it will come here. If x is less than 0, then it will print x is a negative number. It will check here whether the condition is true or false. X is greater than or equal to 0, it will be checking in this step. If it is positive, it will print it is the number is positive. If it is negative, it will come to the next step for checking. If x is less than 0, then it will print it as a negative number. This is the algorithm. Okay, this is the algorithm step-by-step process. Now we are going to add two numbers. Okay, so for that, first of all, we are starting. Step 1 is start. Step 2 is what? We are here. How many numbers we need? For finding positive or negative number, we need only one number. For adding two numbers, how many numbers we need? Two numbers we need. Consider it as A, comma B. Okay. Now, the next process is what? Adding and the two numbers and storing the result in C. So, how it will be? C is equal to A plus B. Here, how we are doing? C is equal to A plus B. But here, how algorithm is a explanation. It is. It does not contain any arithmetic calculations or nothing. Just it is an explanation given. Okay. So read two numbers A comma B, then add the two numbers and store the result in C. Now which one you have to print? You have to print the result C. That's all. Okay. So next we can see the characteristics of algorithm. So algorithm, it has a input, it has an output statement, then it has the finiteness. An algorithm must always terminate. Finite infinite, it should not be have a infinite. It should be always finite number of steps. It should have a start and a stop step. Okay, so only we are mentioning here start and stop. It is a finite step. It is ending. Okay, that should be there. Then definiteness should be there. Each step of an algorithm must be precisely defined. Very accurately it must be defined. No unambiguousness. Confusion should not be there. Definiteness should be there. Confusion should not be there. Then each and every algorithm should be very effective. Okay. So it because this algorithm we are going to transfer into flowchart and program. Okay, once we develop an algorithm for once we develop an algorithm, next step is flowchart. The next step we are going to convert the particular algorithm to pseudocode. Next step we are going to convert that pseudocode into program. So this is the basic thing. So everything should be accurately defined. Okay. Next we are going for flowchart. Here I have to ask everyone: did you understand algorithm? Everyone, did you understand algorithm? So what is an algorithm? Can you say? Any one of you can answer. Algorithm is a step-by-step procedure to solve a given problem. Okay. What is an algorithm? Algorithm is a step-by-step procedure. Okay. It is a step-by-step procedure. Next we can go for the next one, flowchart. Very easy thing, flowchart. Flowchart is a graphical representation of an algorithm. Okay. Now we studied about the algorithm. The next step is what? Flowchart. Flowchart is what? It is a graphical representation of an algorithm or a portion of an algorithm. Okay. Then it is a diagrammatic representation of how to solve the problem through flowchart. It defines. It defines through a diagrammatic representation to solve a problem, to solve a given problem. These are the symbols used. Okay, so in algorithm we have a start and stop step. For that we are using this oval represents the start and end step. Okay, this arrow line connected with arrow. Okay, this is called as an arrow which represents the relationship between the shapes. Next step, it leads to the next step. Then the process. See, this symbol represents the input output, the parallelogram. The parallelogram symbol represents the input output process. Okay, input output step. Then rectangle box, it represents the process, the calculations. A C is equal to A plus B. This everything lies here. Here we are writing read and what is the input and output? Read and print. Okay. So read and print is written inside this parallelogram, and in this rectangular box we are writing the process. Then this diamond shape is the decision making step. Yes or no? Either yes or no. We checked no. See here, in this in this thing, we checked whether the given number is positive or negative. So this diamond shape, the diamond shape, no, it will decide which one is positive and which one is the negative. So these are the flowchart steps. For example, we are going to write an algorithm for finding area of the circle of radius. Area of the circle. Okay, area of the circle which has radius r. Now we are going to, first of all, if you have if they are asking a question like this, first of all you start with an algorithm, next you go for the flowchart, next you go for the pseudocode, next you go for program. Okay, see here, first of all what you have to write? Start. Then we are reading the radius. This is the input. If we give the radius of the circle, what will be generated? Area of the circle will be generated. If you give the radius r of the circle, area of the circle will be generated. Area of the circle is equal to pi r square. Okay, so how it is written? Pi star r star r, pi r square. So now the print area, now the area is printed here. This we can see in the diagrammatic representation. Start is used using this oval symbol. Okay, then the input and output are inside the parallelogram symbol, and the process area is equal to pi 3.14. That is the value for pi. Then star r square. No, so here written 2r star r. Then we are printing the area, then end. That's all. This is the simple flowchart without any decision. Decision means diamond shape. Here we are not using for anything. The coming example we can see. See here. Here this is the program. It is a flowchart to two numbers and find their sum. That is a plus b. Here it is given n1 plus n2. First of all, we have to start with the step 1 is equal to start. Step 2 what? Read. That is the input for input statement. User is giving two number n1 and n2. For that we are using the keyword read. Okay, read the first number n1. Then step 3, read the second number n2. Two numbers we are reading. We are getting as an input. Then what we are giving? We are plusing it. Sum is equal to sum n1 plus n2. Now what you have to print as an output? Print the sum and stop the function. Okay. Here, when we see the flow chart, start is represented using this symbol, read n1 and read n2. These two are given inside the parallelogram symbol. Then the process, sum is equal to n plus 1. It is given inside the rectangular box symbol, and print sum. It is given. It is so input and output statements are given inside parallelogram. Read is the input statement, print is the output statement. Print is sum, start. Now we can see the flowchart using decision box. Here you have to check two numbers are given. For example, A and B is given. We have to check which number is greater, either A or B. Okay. So for that, first of all, we can go with an algorithm. First start, then we are reading two numbers. In this manner also you can write. Read the first number A, read the second number B. Like that also we can write. Okay. Here in one step, it is given. You can write it as step-by-step process. Earlier example you can follow. Okay, here read the first number A, read the second number B. Then we are checking if A is greater than B, then A is big. Then step 4 we can add this one. Otherwise print B is big. In 2 steps we can write. Okay. So in 2 steps we can write, then end the process. So here, first of all, start the program with this symbol. Then inside the parallelogram, what are the things we have given? Read A, comma B. Okay, 2 numbers. Now it is checking inside the decision box. This is the decision box. If A is greater than B, if it is true, then print A. If it is false, print B. Then both the things end with the end statement. Okay, once again, start, then 2 input signal A and B, that we are writing read. Read means input signal, input statement. Here in flowchart. In flowchart, read is the input statement, A and B. If A is greater than B, if it is true, if A is greater, then what you have to print? Print A. If A is not greater, if it is false, then print B is the greater and end the process. This is the flowchart using decision box. Then students, till this did you understand? Next we are going for pseudocode. Till this you understood or not? Did you understand flowchart and algorithm and flowchart? Did you understand, everyone? Okay. Okay. Next we can go for another one thing. Another one, this pseudocode. Pseudocode is nothing but it is the mimic of the C programming high level programming instruction. It is a mimic. Some changes only, but just like a programming language. Whatever statement you give in a programming language, that we will be using in the pseudocode. Okay, so pseudocode, see, what is this? Set of instruction that mimics programming language instruction. Pseudocode is one of the tools that can be used to write a preliminary plan that can be developed into a computer program. First, also programmers, first they start with algorithm. Next, they convert that algorithm to flowchart. Next, they convert that flowchart to pseudocode. Next, they convert the pseudocode to programming language, C or C++, Java, any programming languages they can convert. Okay. Pseudocode is okay. It is a tool. Okay, for writing a big program. Going inside a programming language, initial stage is pseudocode. Okay, pseudocode is generic way of describing an algorithm without use of any specific programming language. It does not use any specific syntax. Programming languages uses some many syntax. See, programming languages for each and every statement it uses syntax. Syntax means set of rules and procedures that we have to follow for writing a programming language. 1 minute. So it is, as name suggests, it is a false code. Pseudo means what? False code. Okay. But it cannot be executed in real computer. This programs cannot, just for understanding, to solve a big problems, we can use this pseudocode, then we can convert to programming language. So this, it is a false code, it is not a true real programming language. Examples of pseudocode for adding two numbers. See, for adding two numbers, initially, all of you listen, this is very, very important. We are beginning the program and ending the program. Initially, we are setting sum is equal to 0. Till now, we didn't add anything. So now, what is the initial value of the sum? It is 0. Okay. Now only we are going for reading two numbers, n1 number n number 2. Now what we are doing, sum is equal to, we are adding sum is equal to sum, num1 plus num2. Now automatically the sum, for example, number 1 is 2, number 3 number 2 is 3, number 1 is 2 and number 2 is 3. Immediately after we are setting this and printing, when we are giving print sum, automatically the sum will become what? 5. Initial value of sum is 0. We have to set. This is the thing we are going to do in programming languages also. First of all, we will be, whatever thing we are using as an output, we are setting it as an initial value. We will be setting empty. First, initially sum is empty. So we are setting sum is equal to 0. Then we are adding and storing the value of two numbers in sum. Now automatically the sum value becomes what? 5. Okay. Now we are ending the process. Again, we are going to write a pseudocode to find the area of the rectangle. So we begin, read, width, comma, length, two things. So because area is equal to width, L into HR is width into length. So we will print the area. Okay. In these cases we have to set. Okay. In these cases we have to set, so that later while I'm teaching the programming language, you will be able to understand everything. Okay. So that's all about pseudocode. Is the informal, not as a formal way of writing. It is an informal way of writing a program. It is not an exact computer program. Okay, it is like a algorithm of a program. Okay, algorithm of a program. but it uses natural language and mathematical notations. Natural languages and mathematical notation. That's all about the flowchart, algorithm, and pseudocode. Did you understand, everyone? Everyone, did you understand? Okay. Very good, very good. Thank you, students. Now, let us study next slide. I'm going to teach you for some time, 10 minutes, okay? We have to start these things also. First of all, you have to know this. So, first module I completed, I think, 1 minute. First module. See, students, first module. See, these things are once again I have completed. You have written an assignment in generation of computer. This slide I will share you today. Sorry, I didn't share anything till now. Today I will share you after completing the classes. So basic organization of the computer we studied, disk, memory, processor, this operating system I will teach you in the class, okay? System software we studied, application software we studied, compilers, you know, in this topic also I will say you about compilers, interpreters, input output unit, algorithms, then representation of algorithm, flowchart, pseudocode. So I have completed more or less. I have completed the first module. It is enough for your first internal. Okay, MCQ. It is enough because we have also only basic questions. The second module, we can start the second module. Second module only till operators. In the class, I will give you the syllabus. Okay, second module syllabus I will give. So if we can start from here. Okay, now we can start from here. Okay, somebody is joining now. Okay, to see what is computer language. If you want to interact with our friends, okay, can you all see my slide? Can you all see my presentation, dear students?
Yes, ma'am.
Okay, okay. See here, what is computer language? See, if a two-person communicate with each other, there we need a language, known language. We need a language to communicate with each other. Likewise, when a user want to interact with a system, computer, they need some language to interact. Okay, those languages we call it as computer language. See, those language is known as computer language. So user interacts with the computer using programs. The programs are called through these programs. C, C++. These are the basic, you know. C, C++, Java, Python. Okay. So for a user, if he want to interact with the system, then he must interact through the programming languages like C, C++, Java. Computer languages and the language through. So these programming languages are written as a program instructions. The instructions that is obeyed by the computer. Whatever instruction you go give, that will be obeyed. So so I will go a little bit fast. I'm not making you bore. I will send this slide also. So I'm not going elaborately. Just a simple thing I will explain. I will structure of the C. I will explain detailing. Okay. So for writing this program, we need some set of rules. That set of rules, we call it as syntax. Take note, okay? So for writing the programming languages, we need some rules, set of rules. That set of rules is called as the syntax. See, computer languages evolved through high level, low level to high level. Computer languages it has come from low level to high level. Low level languages, already I have explained everything in this in your class. Low level language means machine language. It can understand only zeros and ones. The instructions are created using ones and zeros. That is binary language we call. Middle level language means assembly. We are use assembly level language. That is assembly language. It uses mnemonics. Mnemonics. Okay, that also I will explain in the slide itself. What is assembly language is there. We are using some mnemonics. That means if you want to add two numbers, we are using mnemonics add a comma b. If you want to store that a comma b in an result or in another one variable, store the result comma c. Store a comma b comma into c. That likewise mnemonics we will be adding in this middle level language. High level language, it is similar to human language. The example is COBOL, Fortran, basics of C, C++, Java, etc. So already we have studied about this low level languages. It is the machine level language or machine code. It has two symbols, ones and zeros. It is written in binary number 1 and 0. Then a computer can directly, the programmers felt very difficult for writing this machine level language program. It is easily understandable by the computer, but the programmers felt very difficult to write this. Okay, they do not any translators or anything. Directly we are typing zeros and ones, and computer easily it will be understanding. This is called as first generation language. Okay, the advantages, disadvantages you learn. Okay, next one is the middle level language. I have already told you middle level language is the assembly level language. Instructions are written using the symbols or letters, digits, special characters, etc. This is assembly level language is called as, these words are called as mnemonics. Okay. So binary level languages are replaced with mnemonics and operands. Operands is add, mul, div, sub. Likewise, opcodes are operands are sorry. Operands means the A, B, C, D operands. Okay, that input values operands, input and output variables operands. Mnemonics means add, mul, sub, div, like that. Mnemonics will be giving. These mnemonics are translated to binary languages. So it uses the translator called assembler. It used a translator called assembler for translating assembly level language to machine language. Once again, these are important thing for MCQ. Okay. So what is an assembler? Assembler is a translator which translates assembly level language to machine level language. Okay. So assembler is a translator which translates middle level language to low level language. The next advantages, disadvantages you learn. High level language. High level language, it is very similar to human level language. What human is writing, that is fed into the computer. Okay, that is given as an instruction to the computer. That is the high level language. The programmer felt very easy for writing this high level language. Okay, easier to understand for, it is easier to understand for us also, this high level languages. Then here see, compiler or the interpreter are used to convert. This is very, very important. See, so machine level, high level languages are converted to low level languages using compilers or interpreters. Okay, compilers or interpreters, what it will do? Convert high level languages to machine level language. The basic high level languages are COBOL, Fortran, basic C, basic C, C++, Java, etc. are high level languages. All these programming languages use human understandable language like English to write programs. Okay. So instructions are converted from high level to low level through compilers or interpreter. That you have to keep in mind. The next we can study about this one. Okay, see, I have already told you, see, machine level languages, zeros and ones, zeros and one. Assembly level language, it is using mnemonics. See, add, here add alone is given. If you want to subtract A and B, sub. Divide A and B, div. Multiply A and B, mul. So these are the mnemonics and operands. These are the operands used. But see, in C high level languages, if you want to add two numbers, just we are giving C is equal to A plus B. In C, C++, Java. How easily we are representing C. Just we are feeding this to the computer. Compilers will translate these codes into low level, machine level language. So once again, machine language, everything runs on a hardware. Okay, everything runs in a hardware. So machine language, zeros and ones, assembly language, and we are giving mnemonics plus operands, and high level language just like human interaction language. So assembly level languages are converted to machine languages using assembler. This you have to keep in mind, assembler. Here, compiler or interpreter will convert this high-level language to machine understandable language. Popular programming languages are C, C++, Java, etc. Compiler, it uses a compiler to convert high level to machine level. What is a compiler? It is very, very important. Compiler is a program. What is a compiler? It is a program that converts high level languages instruction to low level language. Compiler do two things. First of all, it finds out the error in a program. See, first it finds out the error, then it gives the error to the display the error to the user. Whatever error it finds, it gives the list of errors to the user. Then it converts the corrected error, full, complete, pakka, errorless code. It converts to low level languages. Okay, that's all about the compiler. So what are the two functions of compiler? First of all, it verifies a program has error or not. If the program has error, it lists out the error to the user. Once the error is corrected, if the code is complete correct, then it will translate the code into low level language. These are the steps in C programming steps. C program to create and execute C program in Windows operating system. Okay, use of the, so first step, create source code. Okay, after typing the code, you are saving the code with the .c extension. See, .c extension. Add .c, multiply .c. Likewise, you are saving the program with .c extension. Then for compilation, what you are doing to compile the program, Alt F9, we are giving for compilation. Then if there is error, it will list out the error. Once again, you have to complete the correct the error, and next you, for running the program, you have to press Control F9. Alt F9 is for compiling, Control F9 to run the program. Okay, to check the result, Alt F, you give, result will be displayed in the result screen. So these are elaborately described. What are the 4 steps here? It is elaborately given here. First of all, source code. Okay, we are saving with .c, then .c extension, then compile source code. So here in a diagram we can see very easily, we can understand this. All of you listen this diagram. First of all, you are saving the program with .c extension. When you give Alt F9, the program is compiled and it finds the error and it lists the error to the user. Okay, so here to here we call it as compilation. Then we call it as the execution. Okay, see, it will give the list of error to the user. Once the error is completed, it will be converted to object file. Okay, it will be automatically, it will be converted to sample.object or add.object. Now the linker I already told you, in C program, for example, we will be giving a header file hash include stdio.h we will be giving. Why? For it is the standard input output header file. So linker, what it is used for? It is linking the header file library. It is linking the whatever header files you are using. Header file starts with hash include. Header files start with hash define, hash include likewise. So whatever you give in hash, that in class we can study detailing while running a program, while typing a program, you will understand. So the program which start with hash. That hash is a library function files. It will be linking. The linker links it, okay, with the header file. Then it will execute the file. It will convert the program to machine understandable language. Then you are pressing Control A and 9 to run. So in processor, it will do the all the calculations, and if you press Alt F in the output screen, you can see the output. Students, once again, should I want to explain this? Did you understand this? What is happening? Did you understand? Okay. So once again, if you want, once again, I will explain this process. First of all, we are typing a C program. We are saving that C program with the .c extension. So this is the problem. Okay, did you understood this till this? Did you understood everyone? Yes or no? Okay, okay. So once again, listen. It will be very useful for your exams. Okay. First of all, source file. That is the file what you are typing. That typed file you are saving. Typed file we are saving with .c extension. And next, when we press Alt and F9, Alt F9, it will be compiled. For compiling, we will be pressing Alt plus F9. So compile, it does two things. What it will do, it will first it will check errors. Next, it will convert the high level language to machine level language. That is zeros and ones. First, next is here inside outside we say compiler converts, but how it converts? First of all, it converts the file to object file. Next, using linker, it connects all the links, all the header files, whatever we used in the program. So, what is happening here? So the next linker is used. Then the compiler converts the high level language to machine level language. Once we press Control F9, it will run the program. Run the program means processing. It is running. It is going to execute. The, the program is executing. So it executes. Execution is done by the CPU. Processor will do the calculations. Processor will do the process. Then when we press Alt F5, it will give output in the output screen. That's all about the how to create and execute a C program. Okay, the same thing, explanation. So now we can see what is C, basic things we can see, and I will conclude this. With this, I will conclude. With the structure, I will conclude everything. Okay. Otherwise, structure even I will take in class before the basics of C. I will complete today. So what is C? It is a high-level programming language. It is a computer programming language used to design computer software and application. We can develop software and application through C. Why do we use C? To design computer software and application. Who invented C? Dennis Ritchie. Father of C is Dennis Ritchie. Okay, he was an American computer scientist, worked at Bell Library Labs as a researcher along with Ken Thompson. Okay, so he was born on 9th September 1941 and till 2011 he lived. Okay, he was called as the father of C. So first, what all the softwares we can use to execute C? C C or C are the applications and softwares used to create and execute C programs. Following Turbo C we can use, Turbo C++, GNU C, code blocks, NetBeans. Through this we can run. These are the softwares that we can use for running C program. Then we can see what is C in depth. C is a structured programming language. It is a specific structure. It has syntax and semantics to write each and every code. Okay, each and every statement there is a syntax for developing this C program. Then it is also known as function-oriented programming language. C++ is object-oriented programming language. C++, Java, we call it as object-oriented programming language. But C is a function-oriented programming language. It was invented in the 72. New language was introduced as traditional C. First, initially, the C name is traditional C. The name of C was selected from the C code. C is the extension of B language. The version of next version of B is the C language. Okay, it's derived from BCPL language that we call it as B language. So first of all, first outcome of the C language was Unix. It uses now we can do C in Windows operating system. But first we can work C in which operating system? Unix operating system only. Okay. So initial Unix operating system was developed completely using it was completely Unix operating system was completely developed using C. Unix operating system itself, it was written by C programming language. So who is the founder? Dennis Ritchie, and he is known as the father of C as well as father of Unix, because initially Unix operating system was developed by C program. C program is very popular till now. It is very, very important in every area because it is reliable, simple, easy to use, and it is the base of all the programming language. Basics of Java, C++, Python, this, that, everything basic is C programming language. Okay. So first of all, C and its various versions. First, C was known as CPL, Common Programming Language. It was invented by Martin Richard. Okay, then BCPL. BCPL means it is the Basic Combined Programming Language. It was also developed by Martin Richard. The next version of BCPL is B language. It is derived from BCPL and it was introduced in the year 1969 by Ken Thompson and Dennis Ritchie. Then the next version of B is C. P language, it is derived from B language. See, so these are the basics of C. CPL, BCPL, B language, then C language. It is also developed by Dennis Ritchie. It is also created on which operating system? Unix. So these everything you study, read once, okay? Next version is ANSI. 1983, American National Standard Institution formed a committee to frame standard specifications for C languages. Okay, some standard specification is added through ANSI. Then C90. So C got ISO certification. ISO certification. They verified its library, its processor commands, this, that, syntax, everything. They verified and they gave ISO certification. ISO. Okay, ISO standardization with its new features. Then C99. Many new features are added to C90 to create a new version of it. So it received these things: ISO, IEC 9899, 1999. Okay, that's all about the C. So shall we wind up, or shall I continue the class? Shall I continue, or you can give a message? You can say in message. Should I continue, or did you understand everyone till now? Okay, I will complete the structure of C alone and I will stop. Okay. So C is a structured programming. There is a certain structure for writing C. So we call it as C is a structured programming language. So every C program and its statement must be in a particular structure. Okay, in a particular structure. We can see the general structure. If we give these things, see the comments, whatever. So title of the program, adding two numbers, we can give this using this thing, that is slash star comments. Comments we can give as we can explain the particular line using this, or we can give the title of the program. Okay, so these can be the comments can be given using slash star comments star slash. Now we can start with the pre-processing comments, header files. Pre-processing comments is called as the header files. Okay, headers hash include, hash define. Okay, if we want to define a constant, we can use to define by pre-processing commands. Okay, then next one is the global declaration. What is global declaration? I will say to you. Global declaration means it is optional. If you want, you can use. Okay, use to declare the variable. In all the function we can use that. Leave it that first. Don't get confused. First pre-processing. Next you come to the main program. As soon as pre-processing means what? Header files. We are adding some header files for printf scanf. In C program, for printing a statement, we will be using printf. For getting the output, this is input statement is printf and output statement is scanf. For these two statements, a common header files will be using hash include stdio.h. That is header input output dot header file. Hash include what? Input output dot header. H is header. That is the preprocessor processing command. Then leave this. This for big programs I will say for you. Global declaration. Always the program, C program, this body of the C program, it must rest. It lies in the int main program. If we can add two things here, int as well as void. Int, if you are using, then it must return. We have to use a return statement. If you are using int main, int void, no need to use this statement. If you are using void main, so I'm not going to confuse you. Main function has, we can use two things. Void means empty. It does not return anything. So here it is mentioned as int main. So this int must return something. Int means integer. Okay, it is not empty. It returns 0. Okay. Next, keep in mind we are going to add two numbers. So local variable, we have to declare all the local variables. If it is adding two integers, then we have to mention here int a comma b. Int a comma b, two integers. And that number we are going to store in sum. So here you have to use another one variable sum. So local declaration, input and output variables we are declaring. That is the local declaration. Now the executable statement, the body of the what you are going to do, sum is equal to a plus b. Here you have to write printf, that executable statement, printf, scanf, that everything detailedly after the first internal. I will explain to you clearly how to write a program, what are the input and output statements, everything. Okay. So inside the main program, what are the things resides? Local declaration, executable statements. If it is int, a return statement is there. So int main, the main program starts with the curly braces and it ends with the curly brace. User then outside the main program, you can use so many user defined function. That is, we are creating functions for our use. Okay, that is the user defined function. This is the structure of C. First of all, this is the comments, whatever hints or come or whatever explanation you have to give for a program, we can use this hash star comments hash star hash. Okay, this does not affect the program, so only we are giving this setup in this setup. Okay, next pre-processing commands means you are using header files, that is the pre-processing commands. Then in the main program, inside the main program only, we are going to give all the executable statements, local variable, everything. Okay, then the main program opens with curly braces, closed with the curly braces, and it has many number of user defined functions. So we can stop here. Are you okay with this class, today's class? Okay, I will share all the PPTs. Thank you for your cooperation, students. Thank you so much. We can wind up the class. Only operators is remaining. The next Friday morning, representative, are you there? Representative?
Yes, ma'am.
Please remember me. Friday morning, first hour, okay? Please
Ma'am,
call
I'm
me.
sorry, please repeat.
Okay. Please remember me Friday morning. I will come and complete the portion. Thank you for your cooperation. Thank you. Thank you so much. Okay, you can leave. You can leave. Thank you so much. All of you can leave.